friends, welcome to the Cathode Rays. Today we are going to see the introduction to the chapter structure of atom. This is the fourth chapter of the science. Let's start this chapter quickly. As you all know that we come across different substances around us. The constituent matter. This matter is made up of small particles called atom. Let us know more about the atoms, its structure and its consistence. Matter is anything that occupies space and has mass. It consists of tiny particles which were called permanu, but later the name was replaced by the atom. The Dalton's atomic theory we will start now. The scientist Dalton was the first one to formulate all the information an atom in a theoretical form as a Dalton's atomic theory. He born in 1766 and died in 1844. His theory was published in 1808. His full name was John Dalton. According to this theory, the following observations were made: all matter is made up of small particles called atom. Atoms are invisible, atoms are indivisible, atom of an element are alike in all aspects. That is, if we walk along the sodium, then all the atoms of the sodium will be same in all aspects. Atoms of the different element are the different. That is, if we talk about the sodium and potassium, then the atoms of the both are going to be different but same among themselves. Atoms of different elements combine in a fixed simple whole numbers ratio to form compounds. Atom can neither be created nor destroyed in a chemical reaction. And after that, let us see the drawbacks of the Dalton's atomic theory. There were certain limitations as observed by this other scientists. They observed by the following. According to Dalton's, an atom was indivisible, but later it was proved that the atom was subdivided into subatomic particles called electron, proton, and neutrons. Atoms of the same elements can be somehow differ from each other. This was proved due to the existence of the isotopes in nature. Similarly, atoms of the different element can be the same. This came into the notice due to the existence of the isobar in the nature. After that, according to it, whenever the compound is formed, it is formed as a result of the combination of atoms in a fixed simple ratio. But it has been seen that the ratio might not always be simple. For example, in a sucrose, that is the C12H22O11, the ratio is not a simple ratio, so its drawback it led to failure of the Dalton's atomic theory of an atoms. After that, let us see the discovery of electron and proton. Discovery of electron was discovered by J.J. Thomson in the year 1897. He took crook tube and arranged it the apparatus and show in the figure which is shown on your screen. The following observation was made when he passed the electric current at the voltage approximately at the 10,000 volts through a gas at the pressure of the at a 1 atm. Then nothing happened as no change were seen. After that, when reduced the pressure to 10 to 2 atm, the whole tube started glowing with green colors. The second after that, the uh, third step, he further reduced the pressure up to 10 to 4 atom. The whole tube stopped glowing, but faint grain which was still at the anode end. To confirm, the fluorescent was placed at the back of the anode, and anode was made permanently when current was passing through it. In the same physical condition, the zinc sulfide screen started glowing, which confirmed the following facts. The following was conclude it proved that at this condition some ray were emitted through the cathode and were traveling through the anode called the cathode rays, consisting of the negatively charged particles. These particles were later called the electron. This is how the electron was discovered. After that, the discovery of proton. It was discovered by E. Goldstein in the year 1920. It was actually discovered with the carrying out an experiment to cathode ray. The apparatus used as the same. The following observation were made. It was seen that the cathode rays were produced at the high voltage and the low pressure. They traveled through the gas in discharge tube. While doing so, they ionized the gas. That is, they took electrons of the gas along, leaving behind positively charged particle of the gas. These particles formed the canal ray and they started moving toward the cathode. These particles are called the canal rays, as they are not produced by the anode as this particle positive charge, so they were named as proton. Now, after knowing about the atom, different attempts were made to know atom structure. Thomson's models of the atom, that is plum pudding model. His full name was J.J. Thomson, and he the he was the one who made the first attempt to explain of the structure of atom. According to him, atom is positively charged sphere in which negatively charged are present and contain certain places like a plum in a pudding and cherries in an ice cream. But this model was rejected. He could not explain the major points seen in the models. Drawbacks of the Thomson's atomic model were as follows: he could not explain the distribution of the charge and the stability of an atom. As we all know, the opposite charge attract each other. So how come it is possible that few negatively charged remains the scattered in this positive space? They would have been neutralized. They could not be explained by the J.J. Thomson. That will lead to failure of these attempts. And after that, let us see the Rutherford scattering experiment. In order to understand the structure of the atom, Rutherford performed this scattering experiment. For this, he looked a gold foil and passed the alpha rays through it. Gold foil actually consists of the many atoms. So at an individual level, we are considered the observation through an atom's alpha ray are actual positively charged rays consisting of the helium nucleus. This ray will pass through the suffer the reflection of the different angles, and to note the movable screen made of fluorescent material was placed around it. When the reflected rays strike that screen, it causes tintilation. When he passed his rays through the gold foil, various observations were seen. Observation were as follow: most of the rays passed straight. Some of the deflect through the small and large angles. Some rays rebounds back. The following conclusion were made: most of the space in an atom is empty. This is sometimes some things in a center of the atoms called nucleus. Nucleus is positively charged. So according to the Rutherford, the structure of the atom is similar to that of the solar system. And he said atoms is electrically neutral. Nucleus is in a center. In the proton are present, which in which proton are present outside nucleus. Electron revolves like a planet revolve around the sun. In this model, also few limitations were seen, and some questions are left unanswered, which led it to its failure. The drawbacks of the Rutherford's experiment were as follows: he failed to explain the stability of the atom according to the electromagnetic theory, and charged particle when revolve in the circular path continuously emits energy and they shorten its path, as we know. And the electron is also a charged particle revolving in a circular path, so it should also emit shorten its path, and should finally fall into the nucleus. And for doing so, it need time lesser than the fraction of a second. But this doesn't happen. After that, let us see the discovery of neutron. It was discovered by the Chadwick in the year 1932. It was actually discovered while considering the mass of the atomic particles. It was in the whole mass of an atoms is due to the nucleus, as far we know the nucleus is positively charged. That means if it was only proton in it, but we also known the mass of an atoms is never equal to be the mass of the proton. This shows that the number nucleus contains the some other particles also. The contributions toward mass only and not toward the charge, therefore the particles were called the neutrons. After that, let us see the Bohr's theory. To overcome the limitations of the Rutherford's model, the the new concepts and the picture of the atoms was considered by the Nile Bohr's, which made a great contribution in knowing the structure of atom. According to it, atom is electrically neutral. Number of proton is always number equals to the number of electrons in the center of an atom's nucleus is present, which is positively charged. The nucleus nucleus, proton and neutrons are present. Protons possesses positively charged and neutron possesses no charge. Outside of the nucleus, shells are the energy level distinguished as K, L, M, N, and so on are present. In the shell, electrons revolves. Electrons are negatively charged. Each shell has a fixed amount of energy, so as long as an electron remains in the same shell, it never loses and gain energy. Number of electrons in each shell is determined by the Bohr-Bury rule in 2n square. Some important definition: atomic number is defined as the number of protons in an atom. Mass number is defined as the sum of the proton and neutrons present in the nucleus of an atom. Representation of an elements where z is equals to the atomic number, where a is equals to the mass number. Atomic number is subscript and the mass number is superscript. Electronic configuration is defined as the arrangement of the electrons in different shells. The arrangement is according to the Bohr-Bury rule, that is 2n square valency cell. It is last shell of an atom. For example, in the case of the sodium, the electronic configuration is 2, 8, 1. In the shells involving R, K, L, and therefore the last shell is M valency cell. Valence electron, the electron present in the valence cell of an atom. For example, in the case of the sodium, the electronic configuration is 2, 8, 1. In this, the shells revolve R, K, L, M. The electronic electrons present in the valence cell are the valence electron that are 1. Valency it is the combining capacity of an element. It depends upon the numbers of the valence shell electrons, that is electrons in the last cell of an atoms, that can be seen by writing the electronic configuration. We have two types of valency, that is electrovalency and covalency. Firstly, let us see the electrovalency. It is the valency that is attended by the losing and gaining of electron. For example, in the case of the sodium, atomic number is 11 and the electronic configuration is 2, 8, 1. So, in order to attain stability, it can either lose 1 electron or gain 7 electron. Out of the two operands or options, losing 1 electron is easier. Therefore, it loses 1 electrons and therefore its valence is positive 1. Covalency, it is the valency that attains by sharing of electron. For example, in the case of the carbon, it can attain stability by sharing 4 electrons. If we look at its distribution, it needs for more electrons, so it completes the octet by sharing the 4 electrons. Therefore, its valence is -4. After that, let us move on the another topic. Let's start this topic, that is the isotopes. They are those elements which have the same atomic number but different mass number. Properties of the isotopes are as follows: the number of proton is same, the symbol is the same, the number of valency electron valency is same. They differ only in the number of neutrons. The application of isotopes: U235 U235 is used as a nuclear fuel. CO60 used to treatment of cancer. I128 used in the treatment of goitre, and C14 is used to carbon dating. For example, in the case of the hydrogen, the isotopes is H1, H2, H3, but atomic number for all is 1. In the case of the isotopes are O16, O17, O18, but atomic number for all oxygen is 8. And then after, let us move on the isobars. They are those elements which have the same mass number but different atomic number. For example, sodium, magnesium are the isobar, have different atomic number and same mass number, that is 24. And after that, let us move on the isotopes. They are those elements which have the same number of electron. Typically, I am telling the isotopes are they are those elements which have the same numbers of neutrons. For example, carbon, nitrogen, and oxygen all have 8 neutrons. The atomic numbers of the various elements along the electronic configuration and valency is given below. Atomic number from 1 to 20 as shown as the element hydrogen has electronic configuration 1 and valency is also 1. And after that, the next element is helium. The electronic configuration is 2 and the valency is 0. The third element is lithium and the electronic configuration is 2 comma 1 and the valence is positive 1. And fourth is beryllium. The symbol of beryllium is capital B and E, Be. The electronic configuration is 2 comma 2 and the valence is 2 plus 2. And after that, boron 2 comma 3 and plus 3 is a valency. And then the carbon, the electronic configuration is 2 comma 4 and the valency is negative 4. Then the nitrogen, the valency of the nitrogen is negative 3 and the electronic configuration is 2 comma 5. And next, the oxygen, the electronic configuration of the oxygen is 2 comma 6 and the valence is negative 2. And the after that, the fluorine, the electronic configuration is 2 comma 7 and the valence is negative 1. And then the neon, the valence is 0 and the electronic configuration is 2 comma 8. And then the sodium element, the electronic configuration of the sodium element is 2 comma 8 comma 1 and then the electronic configuration is plus 1. And the next, the magnesium, and the electronic configuration of the magnesium is 2 comma 8 comma 2 and the valence is plus 3. Sorry, not a plus 3, it is a plus 2. And after that, there is a aluminium. The valency of the aluminium is plus 3 and the electronic configuration is 2 comma 8 comma 3. And next is silicon. The electronic configuration of the silicon is 2 comma 8 comma 4 and the valence is negative 4. And after next is this phosphorus, and the valency the electronic configuration is 2 comma 8 comma 5 and the valency is negative 3. After that, the sulfur is begin and the electronic configuration of the sulfur is 2 comma 8 comma 6 and the electronic configuration is 2. And next, the chlorine is begin and the electronic configuration of the chlorine is 2 comma 8 comma 7 and then the valence is negative 1. And the next is the argon. The valency of the argon is 2 comma 8 comma 8 and the valency is 0. And then the potassium, the valence electronic configuration of the potassium is 2 comma 8 comma 8 comma 1 and the valency of the potassium is plus 1. And then the calcium, the valency of the calcium is plus 2 because the electronic configuration is 2 comma 8 comma 8 and comma 2. In this, there is a 2 is a valence electron and the valency is 2 because it gives the 2 electron to others. Then after, let us move on the next topic. There were no topics, therefore the chapter is end at this point. After that, let's start the summary of this chapter in a few minutes. Atom is the smallest particle of an element. It has two parts, nucleus and the outer nuclear parts. The nucleus of the atom consists of proton and electron. Proton are positively charged and positively charged particles. Neutron possesses no charge. In outer nuclear part, the electron are present. Electron are negatively charged particle. Atomic number represents the number of proton in atoms, as atoms are electrically neutral and atoms contain in many electrons. As it has proton, the total number of protons and the neutrons present in one atoms of an element is known as its atomic mass number. The arrangement of the electron in the various shells, orbits, or energy level of the atom of the elements is known as the electronic configuration. Atom of a given atomic number can have different number of neutrons are called the isotopes. And the next is the atom of different element which have the same numbers of same mass numbers but different atomic number are called isobars. These have the different number of proton but equal sum of the numbers of protons and neutrons. atom of a given atomic number can have different number of neutrons are called the isotopes. The atoms of the different elements have the same number of the neutrons but different atomic number are called the isotones. At this point our video is end. Thanks for watching this video.